Hi, welcome everybody to the Schuko Math Practice Lab, Learning Through Practicing. And today we will continue the limits unit, and we're going to talk about the practice set number 5. In this practice set, we're going to focus on how to find the limits for the absolute value functions, okay? So here are the 6 problems we're going to practice. As you can see, they're all involved with absolute values. I'm going to show you how to find the limits with absolute value functions here. Okay, so now if you want to pause the video and try to figure out the problem by yourself first, right now it's a good place to pause it and then try to practice yourself first. And then when you finish, then resume the video and come back and we can check the answer. Okay, and now I'm going to go to the whiteboard and I will talk to you later. Okay. Hi, everybody. And I'm back in the whiteboard. Okay, so as always, before we try to do the problems, let me give you a very brief review. What are the key knowledge or techniques we need to know? Because we are talking about absolute value here. So the first thing is, in order to find the limits of absolute value function, the first thing is we need to be able to break the absolute value, the sign, to get rid of the absolute values here. So how do we do that? So if the absolute value of x, we have 2 ways to break it. So it will become to the x if the x is greater than or equal to 0. This is pretty obvious, right? So for example, you see here, right? So we say the absolute value of the phi. What is the absolute value of the phi? Will just be the phi itself, right? How about what is going to happen if the x is less than 0 here? Okay, so let's take a look at these examples here. So if I have -7, everybody know the absolute value, doesn't matter you have a negative or positive inside, it will give you what? It will give you the positive value. So the -7 will become the +7. So what is how do I get the +7? So think about here, this is my x's, right? So the +7 really will be the -7's, right? So that will give you +7. So what is the -7 here is -x. So that's why we said, the way to break out the absolute value sign, if x is less than 0, you need to have what? You need to have a negative sign in front of it. And this is the part a lot of the students, frequently got confused about it, right? So don't forget this is very important here, right? Okay, now after we review it, we can start to work on our problems here. Let's take a look at part A here, problem A. So I have a limit x approach to 3, and then this is 2x plus x minus 3. Okay, as always we say, first let's take a look from the left-hand side. Okay, so from the left-hand side, that means I approach to x from the value less than 3, right? So if x is less than 3, what happened to this value here? So whatever inside this absolute value function will be a negative. So now I know from the things we just reviewed, so if this one's here, so it's from the left-hand side. If this is negative, what you need to do? You need to put a negative sign, right? So the negative sign in front of it, right? So so that's how do you break out the absolute values here. Then here you will have a limit x approach to 3 from the left-hand side. So this will be 2x minus x plus 3. So will be x plus 3. So this will be the limit x approach to 3, the negative, so it's x plus 3. So get rid of this. Okay, so what is the answer here? So this will be 6, right? So let me see if I approach from the left-hand side, it will be equal to 6. Okay, so now let's take a look if I have a limit x approach to 3 from the right-hand side here. So this is a 2x plus x minus 3, right? Okay, so now take a look. If you approach from the right-hand side, that means x is greater than 3. So that means whatever inside here will be a positive values, correct? Okay, because it's a positive, and then based on the absolute value, when we break it out, absolute value, you can just remove the absolute value because it's a positive, right? So this will be x minus 3. So what is this one's here? So this will be limit x approach to 3 from the right-hand side is 3x minus 3. So it's 9 minus 3 is equal to 6. Okay, so great, right? So my right-hand side, what happens here? My right-hand side equal to left-hand side. So what is my limit for this problem here? So limit for this problem exists, right? So limit is 6 here, correct? Okay, so be very careful. If you remember this rule, how to break the absolute value, then you'll be able to solve all the absolute value problems. I think you shouldn't have any problems here. Okay, now let's take a look at problem B here. This is limit x approach to negative 6. Then this is 2x plus 12. And then this is x plus 6. Okay, so now let's take a look. You still do the x approach to negative 6 from where? From the left-hand side, right? From the left-hand side here. Okay, now you have, this is 2x plus 12. I can factor 2 out, so this is x plus 6. So this is x plus 6 here. Okay, so now take a look here. If the x is approach to negative 6 from the left-hand side, that means x is like a negative 7, maybe negative 6.5. So we know what happened to here. So all the values here are going to be what? Will be a negative, right? Correct? Okay, so now based on my limited definitions here, I said absolute definitions here. If I approach from the left-hand side, so this one is 2x plus 6. Then because of this is negative, so I break out the absolute value. I need to put a negative sign in front of it. And then after that, and you say, oh, wow, so this is x plus 6, you can cancel. So what is the answers here? It's negative what? It's negative 2. So correct? Okay, so now let's take a look at limit x approach to negative 6 from the right-hand side here. Okay, so this is the right-hand side. Okay, so now you take a look from the right-hand side. That means the x will be like a negative 5.8, negative 5.9, right? And so if x is negative 5.8, negative 5.9, so what is x plus 6? It's going to be a positive value. So correct? So if it's a positive value, then what I can do, I can just take the absolute value out, right? So this is x approach to negative 6 to the positive on the right-hand side. So this is x plus 6. Because it's the positive, so I can just remove the absolute value. And then I can have an x plus 6. So boom, boom. So what I have here, I have 2's here. So as you can see, as you can see, from the right-hand side, I have 2. From the left-hand side, I have what? I have a negative 2. So they're not equals, right? So what happened to my limit? Do not exist, right? Because these 2 is not equals, right? So that's why, we know the limit is not exist. Okay, let's take a look at problem C here. Okay, so the problem C, like we talked before, as long as you know how to break the absolute value, then I think you will be good. Okay, so this is 0.5 to the from the left-hand side. So this is 2x minus 1. Then this one here is 2x cubed minus x squared. Okay, so before I even do anything, so let me simplify it a little bit. This is 0.5 from the left-hand side, right? So we try to approach from the left-hand side. Okay, so this is 2x minus 1. So inside here, I can factor the x squared out, right? So this is 2x minus 1. And because of x squared is going to be always positive, correct? So I can move the x squared outside the absolute value because it doesn't matter because you know, the x squared will be always positive, so I can move that out. Okay, now let's take a look. Because I'm going to approach the 0.5 from the left-hand side, that means it's the value going to be what? Going to be smaller, right? So like a 0.4 or 0.45. So then if it's smaller than 0.5, what happens here? What happens here? So here will be what? Will be always negative values, correct? Okay, so now because of that, I know I can, if I break this, so this is x squared, right? So this is 2x minus 1. Because this is always a negative value, so when I break the absolute value, I need to put a negative sign to the 2x minus 1. Right? So because this is how do we break the absolute value. And then now you see here the 2x minus 1, 2x minus 1, you can cancel out. Then when x approach to 0.5, so it will really just be negative 1. So this is 0.5 to the what? Squares, right? So you will get a negative 4 here as your answers here. Okay, now let's take a look at part D here. So the part D, this is the limit x approach to negative 2. Then this is a 2 minus the absolute value of x, and then this is a 2 plus x here. Okay, so now for this ones here, right? You know, we have the negative 2, so let's try to do here. X approach to negative 2 from the left-hand side, right? Okay, so this is a 2 minus x. This is a 2 plus x. Okay, because, you know, this is the negative, from the left-hand side of the negative 2, that means it could be negative 2.11, negative 2.42. So the whole thing here is negative. Right, so if a whole thing here is negative, what I need to do, so here this is an x approach to the negative 2 from left-hand side. So I take it out of the absolute value, I need to add an absolute sign in front, right? So here, this will give you, this is a limit x approach to negative 2, and this is 2 plus x and 2 plus x. That's pretty good. Boom, boom, cancel. So what is the answers here? It's 1s here, right? Okay, so the same way, let's take a look at x approach to negative 2 from the right-hand side here, right? Okay, so x approach negative 2 from the right-hand side. So this is a 2 plus x, and this is 2 minus x here. Okay, so as you can see, even from the negative 2 from the right-hand side will be like a negative 1.99, negative 1.97. So here, inside here, still is a what? Still is a negative values, right? So if it's a negative value, how are you going to break it? Okay, so this is the x approach to negative 2 from the positive. So this is a 2 plus x. Remember, if a negative, you need to add a negative in front of it in order to break the absolute value sign. So this is a negative 2 to the positive right-hand side. So this is 2 plus x, 2 plus x. Whoa, that's pretty good, all right? Boom, boom, cancel. What is the answers here? It's 1. Okay, so because the right-hand side equal to left-hand side, right? So these two equal. So does my limit exist? Oh, yes. What is the limit? Is 1. It's good? Okay, it's very good. Okay, so now let's do the next one. Okay, let's take a look at problem is here. Okay, so now this one here is limit x approach to 0 from the left-hand side. 1 minus x, this is 1 minus 1 absolute value x. Okay, so now I'm approaching to 0 from the left-hand side. So what's that mean? That means here is always negative, right? From left-hand side. So now in order to break out the absolute values here, this is 1 over x. So what do we need to do? If it's negative, I add a negative in front of it, right? So this is limit x approach to 0 from the left-hand side. So this is 1 over x, and here negative will become what? Become positive, right? So plus 1 over x. So I have a limit x approach to 0 from the left-hand side, 2 of x, right? So it will be what? It's negative infinity. So the limit not exist, but it's going to the negative infinity. Okay, so now let's take a look at f here. So it's the same problems here, right? So instead of approach to the left-hand side, I'm approaching to what? I'm approaching to the right-hand side here, right? So this is 1 over x minus 1 over absolute value of x. Okay, so let's take a look, right? So x approach to the right-hand side. This is 1 over x. So take a look here. Since this is approach to the right-hand side, that means all the values here is what? Is positive. If it's a positive, what do we need to do with the absolute value? You can just take the absolute value out. So it's 1 minus x here, right? So this is limit x approach to the 0 to the right-hand side. Then x minus 1 over x minus 1 over x is what? It's 0. So you approach to a constant. So what is the answer? Answer is 0, right? So that's why this will be the answers here, because the approach to 0 from the left-hand side is not equal to the approach to the 0 from the right-hand side. So I know if the problem want to find the problem x approach to 0, 1 over x, 1 over absolute value of x, these ones here do not exist, right? Because left-hand side 0 is not equal to right-hand side 0. And that's it. That's how do we do the absolute value function. So remember, right? So in fact, the absolute value function, try to find the limit is pretty easy. But just try to remember, right? When you break the absolute values here, this will be x if the x is greater than or equal to 0, and this is a negative x. If x is less than 0, if you can remember this rule, I think you will be able to do that. Okay, that's it for this practice. And I hope that now you will be pretty good at how to find the limit for the absolute value functions here. Okay, so don't forget, you know, practicing, and practicing, right? That's the way you will make you getting better in maths. And looking forward to talk to you our next practice set. We're going to introduce some general functions and how do we use a factoring technique to find the limits here. Okay, so nice to talk to you again, and looking forward to talk to you in the next practice set. Okay, have a good day, and bye.